Hello again everyone. So previously we covered theory for the chapter 2 of class 11th NCERT mathematics, that is relations and functions. Now what we are going to do is we are going to cover few miscellaneous problems and perhaps a few unsolved problems which might help you to understand the concept in a better detail. We won't be using any other concept. Whatever concepts were covered in the last lecture, like the theory section, we will be using those only, and then we will be trying to solve some questions. Right? So let's take something example. So I have an example here with me. So it says let R be the set of real numbers, right? So they are saying there is a function f which is defined from R to R, right? So first of all, what does this thing mean? It means the function is defined from a real value to a real value. So the domain of the function is a real, and the codomain of the function is also real. So it's a real values function. First of all, this is called a real valued function, right? So this is a real valued function. Now what they are saying is it is defined as fx is equal to x plus 10, right? So what does this mean, right? It means for any x which is real, right, the value corresponding image. So for each x, the image is given by this relation, right? So it means if I put x as 1, this implies that fx is equal to 11. If x is equal to 5, this implies that fx is equal to 15, right? So first, right? Now when we see we had a identity function where y is equal to x, it's a linear function, right? So similarly, this is a linear function. If x plus 10 is a linear function, and a general form of a linear function, the general form is ax plus b, right? Y is equal to ax plus b, which is the equation of line itself, right? So now what they are saying is, can we plot this? The idea is they are asking to plot it, right? So we know that it's going to be a line. Now, essentially what they are asking is to plot a line which is y is equal to x plus 10, right? So we know the equation of line, so it's almost like so. Even if you don't know the equation of line, let's say we have a value of x as 0. When we have x is equal to 0, then y is equal to 10, okay? Then it's 0, 10, right? And when x is equal to 5, so suppose 1, 2, 3, 4, 5, then this is equal to 15, that's somewhat here. So I know that this is the line that we are asking for, right? This line passes from, so this is the, this is the equation, there's the graph of the function. So essentially what we can do is we can plot a few points and then understand that it's a linear function or a quadratic function, and then we can use it to plot it, right? So that's one question that is there in the NCERT, right? Now, based on the similar concept, there are many other questions. So, okay. So suppose there is another question which says, so they are saying that f again is a linear function. F is a linear function. It's a linear function, right? Wherein, it's a function in, it's not a real function, it's a linear function. It's a linear function which is divided over integers. That is z, right? And they have given certain values. They have given some more values, okay, they have given 1, 1 is 1, right? So they are saying 2, 3 is 1, and then they are saying 0, minus 1 is 1, and also minus 1, minus 3, right? So there are these values. Okay. So now, as I said, linear function have a general form ax is equal to b, y is equal to x plus b. Now there is a function wherein these things are getting mapped, right? So I know that 1, 1 satisfies this. So if I put this value these are the x, y's, right? If I put these in this equation, so I will get 1 is equal to a times 1 plus b. This implies that a plus b is equal to 1. That's one equation. And if I put these 2, 3 in this, so I will get 3 is equal to 2a plus b. Right? There are two equations. Okay. So now if I see there is a plus b is equal to 1, right? Now simply subtract this, I get a is equal to 2 2, when I get a is equal to 2, this implies that b is equal to minus 1. Right? So a is equal to 2 and b is equal to minus 1. So our linear function is 2x minus 1. Let's see if this is satisfied, right? So we are saying x is equal to 0, then we are getting y is equal to minus 1. This is fine. When we are putting x is equal to minus 1, then we are getting y is equal to minus 1. So this is our function, right? So once we know few values and we know what's the general form, we can try to predict the entire function or it could be, right? Okay, so this is another problem which is again given in the NCERT. Now let's take another example. So now they are asking for the domain of a function. So these are very typical questions that you get in day in and day out. Like, so there is a function fx. First of all, let's see what it is. So x square plus 3x plus 5, right, divided by x square minus 5x plus 4. Right. So first of all, let's see what sort of what sort of function are we seeing here, right? It's a polynomial function. All the power of x are integer. This is again a polynomial function. So it's a format of p1x upon p2x, right? It's called the rational function, which I told you, right? It's a rational function. Rational function, right? Now they are asking for the domain. Domain means, like, what all values of x can I put in here. Now I know I've told you, like, whenever there is a function which is a denominator. So I said, like, for rational, p2x should not be equal to 0, right? That was the condition that we had, right? So this p2x should not be equal to 0. So if I see this thing, so my only point is, like, x square minus 5x plus 4 should not be equal to 0, right? Else I'm fine with everything. Whatever you put here, everything is there, right? So my domain is ideally, domain is equal to r minus some solution for this equation, right? So it should not be equal to 0. So what I do is I equate this to 0, and whatever are the values, I remove it from the real values. That will become the domain of this function. So this is easy to solve, right? This is x square minus 4x minus x plus 4 is equal to 0. Taking x as common, x minus 4 minus 1x common, x minus 4 is equal to 0. Taking x minus 4 and x minus 1 is equal to 0. This implies that x is equal to 4 and x is equal to 1. Solve this. So my domain is r minus 1 comma 4, right? So I remove this set from all the real values, and whatever set I am left with, that is the domain of this function, right? Okay. Yeah. So that's another question that is there. So finding domain is a typical question that we get. Generally, domains are like, denominators can't be equal to 0, right? Or anything which is under square root can't be equal to 0, right? Can't be negative, right? So they can be 0, but they can't be negative. Okay. So suppose my point is, like, there is a function. Suppose this is a short question in NCERT wherein they ask, say, okay, what's the domain of the function x minus 1, right? So I know for this to be true, I cannot have something like, minus 4, right? I cannot solve it. It's a problem of imaginary numbers, right? So for this to be true, x minus 1 should have to be greater than or equal to, because 0 is allowed. That means x is greater than or equal to 1. So in the number line, this is 0, this is 1. So this entire region is my domain of the function. This function is not defined for any value which is less than 1. Right? So this is another sort of problem, that you can solve for, like, what's the domain, right? Okay. Now, there is another problem in NCERT wherein they are asking to sketch a graph, like, okay, of a function. So the function that is given is fx is equal to, it's defined in 3 ways. So it's defined in 3 ways, it's written like this: 1 minus x for x less than 0, right? And then it's defined as 1 if x is equal to 0, and it's defined as x plus 1 when x x is greater than 0, right? So what it means? So x is a function. You can put some values, real values. Now whenever the values of x, right? So whenever the values of x, suppose this is 0, right? So whenever the value of x is this, the value of the function at this point is 1, right? So this is this thing I know, right? So this is 0, 1, right? So whenever the value of x is 0, function value is 1. But the point is, when it is greater than 0, then it's x plus 1. So now, what does this mean, right? So it means, whenever I am at like 0.1, the value is 1.1. So it's like starting from here. So it's almost like this sort of graph here. And likewise, it's 1 minus x. So when it is negative, so when I am minus 0.1, so it's 1 minus minus 0.1, 1 minus minus 0.1, which is nothing but minus, which is nothing but 1.1, right? Again, the same value. So it's like this, right? So this is the graph. So essentially what's happening is, this is nothing but, this is almost equivalent to saying, if you remember this was a modulus graph, right? This is a modulus graph, right? So this is nothing but equal to, if you are shifting it by 1 plus modulus x, right? This is almost like equal to saying 1 plus modulus x. Hope I am correct. Yeah. So let's say minus 0.1, so I am increasing it by this, right? So this is almost equal to saying this, right? Now, so these are the few problems that are there in the NCERT. In addition, let me just see, like, if there are some good problems in the, to be solved, like which are not almost solved. So suppose I'm saying they are given this thing, so gx, right? Gx. So they are saying gx is equal to x square, right? For x greater than or equal to 0 and less than or equal to 2, right? And they are saying it is equal to 3x for x greater than or equal to 2 less than or equal to 10, right? So first of all, I see that what's the domain. If it is a function, first of all, if it is a function, then the domain is like, x is from 0 to 10, right? Both are included, square bracket, this terminology that we have already used, I have already explained in lecture 1 of sets. So, both are inclusive, so this is 1, and the function is changing at the value 2, right? Now let's see, if I put the value 2 here, so what happens is, if I put the value 2, I get the value 6 by this. But when I put 2 here, I get the value 4, right? So what's happening, like, if I have a value of 2 in the domain I have a value 2, it's getting back to two things, right? It's getting back to 4 and 6 in codomain, right? I told, like, function cannot have a divergence, it can have a convergence, right? So since it's diverging, it's definitely not a function. One value, we are applying a function on this, and I'm getting two values, right? Definitely it's not a function, right? So these are very, trivial sort of problems. On the same concept, there are few times, like, in IDJE screening, or we are used to have screening papers, right? They ask very, quick questions, right? And people should be able to see that, okay, what's actually happening here, right? Now, for example, what happens here is, it's a very easy question, okay, almost on the same concept. So I say, there are two graphs. So for that matter, there are three graphs, right? There are three graphs, okay, this. One graph. Second is this graph, and the third is, say suppose, this graph, right? Which of these graphs, say suppose graph A, graph B, and graph C, which of these graphs cannot be a graph of function, right? Okay, now what I know for function, it should be real, okay, real values are being plotted and all those. The only thing is, like, if I draw a line which is parallel to y-axis, so suppose what happens is, I'm checking the value of function at this point, right? What I have to do is, for that, I have to draw a line parallel to y-axis, right? You should cut the function graph at only one point, right? Because the moment it cuts at 2 points, I'm getting two values, right? Same thing is here, but now for this case now, let's see. We are saying this is the value of x, and we are drawing a line parallel to y-axis. It's cutting it at this point and this point, right? So for the same value, say suppose this is value 1, 0, x value is 1, we are getting two values of y, right? Okay? So this cannot be a function. This is definitely not a function. Not a function. Right? So very easy thing to see, but like people might say, okay, it's continuous, not discontinuous. I don't know what is this and all those, but suddenly you can see that if this thing is falling, this is definitely not a function. Okay, so perhaps these are some basic problems that can be solved in functions. We'll try to cover more from IIT JEE problems and some other competitive exams because there are many problems that come with CAT as well. I will see like when you do your engineering and then post that if you plan for MBA or any other entrance exam, if there are some specific questions that are covered on function, I will try to cover them here. But yes, more and less these are the concepts which are used, right? Okay, great. Thank you for this. We'll see you in the next lecture.